A very warm welcome to everyone. I'm Subhasish, Product Manager for Google Cloud Storage or GCS, and I have with me Chester, Tech Lead for GCS as well. And in this session, we are going to learn about some important security capabilities and best practices to keep your data safe and secure at scale on GCS. So, agenda first, we are going to look at GCS as a product and its various capabilities. Then, we are going to go through some highly differentiated security fundamentals that GCS has to offer, and then Chester is going to take you through some highlighted security features and some security best practices to secure your data at scale. And then we are going to end with a demo, which will put together these various security capabilities and best practices. So, introduction: what is GCS and why it is awesome? So, GCS or Google Cloud Storage is GCP's object or blob storage product. It's a very simple product to use from the customer perspective because of various reasons. But two fundamental reasons. One is that GCS offers a consistent API across all different storage classes. And the second is GCS offers uniform online latency characteristics across all different storage classes. So whether you are interacting with the hottest storage class or the coldest storage class, your code doesn't need to change because the API is the same. And your handling in the code doesn't need to change because across all these different storage classes, you have the same online latency characteristics. GCS is highly reliable. GCS offers various geo redundancy options ranging from a region to a country to a continent based on what your use case is. And GCS is highly cost effective. You can leverage object lifecycle management to spread your cost across all different storage classes of GCS. Now, last but not the least, and the focus of this session, GCS is highly secure and is inbuilt with a bunch of fundamental security capabilities that you get straight away off the box when you use GCS. So, in terms of key features, I have already mentioned about the unified experience through the APIs and the latency characteristics. So, GCS offers strongly consistent listing worldwide, and what we see is, other than GCS, when other public cloud storages are being used, customers usually use a key value database to drive this consistency because they do not get it off the box with other public cloud storage offerings. But that is an additional unit of cost and management, which you do not have to do with GCS. I've already mentioned geo redundancy. The other great aspect of using GCS is you do not need to worry about scale at all. We have single customers in GCS who scale to exabytes of data. Now, in terms of the use cases, we see standard storage class being used in two different classes of use cases. We see dual regional and regional standard location types being used for highly compute intensive use cases. For example, for high performance computing or for analytics or for machine learning. What we also see is customers leverage GCS's multi-regional storage locations, CDN-like characteristics because of its intelligent edge caching and routing capabilities for content distribution use cases. And nearline is great if what you are looking to do is backup. Cold line is great if what you are looking to do is archive. And the archive storage class itself is great if what you are trying to do is to do long-term archival for regulatory or compliance purposes. So what we see is archive storage class is a great tape replacement, but once you have your data in archive storage class, your data is still live, it's in a serving tier. And that brings me to the fact that once you have your data in GCS, you have this great advantage that the entire data platform that is Google is now open to you. So once you have your data in GCS, whatever it is that you want to do with your data, whether you want to run AI or machine learning, or you want to do analytics, whatever it is that you want to do, you can do once you have landed your data in GCS. Now, security is not an afterthought for us in GCS. We have built GCS with security as a fundamental primitive, and this starts with Google's private network. So, Google possibly has the world's largest private network. So, we have thousands of edge node locations, we have hundreds of pop node locations. So, wherever you are producing your data or consuming your data from, you are never too far away from one of Google's edge or pop locations. And how that helps you a lot is Say if you are in a particular location and you are writing your data to a Google Cloud Storage bucket in a different region, with GCS, your data packets enter Google's closest POP, and then it traverses Google's private network all the way up to the region. Now, if you compare it with another public cloud vendor, what would happen is your data packets would pass through the public internet up to the region where your data is stored. So you have much higher exposure that way. When you use GCS, your data packets are flowing through Google's private network for most of its lifetime. So your exposure to public internet is as low as possible. Encryption is another very important aspect of uh, security, and with GCS all your data is always encrypted. So whether it is your data in flight or whether it is your data at rest, all of your data in GCS is always encrypted, and we offer you entire range in terms of choice for managing your encryption keys. So whether you want to use customer supplied encryption keys, or you want to use customer managed encryption keys, or hardware security module, or you just want to use Google's default automatic encryption, you have all your choices when you use GCS. And then the last part that I would emphasize on GCS's fundamentals, security fundamentals, is even if you use the most sophisticated security capability with GCS, for example, if you use KMS keys, or if you want to put your GCS buckets behind a VPC security firewall, you do not have to pay any penalty in terms of your performance or your SLAs. We have built all the security capabilities with GCS from ground up, so that your experience of using them is the same as if you are using GCS even without these features in terms of the performance and the SLS. There is absolutely no penalty that you need to pay. With that, I'm going to hand it over to Chester, who's going to take you through some security features and some best practices, and then we are going to end with the demo. Take it over, Chester.
Thanks, Shub. The features I'll be going over today are uniform bucket level access, IAM conditions, service account HMAC keys, and V4 signatures. Uniform bucket level access went GA last year, and this is a bucket level setting that lets you simplify access control across all objects within a bucket. When enabled, permissions are managed using the bucket's IAM policy, disabling the use of individual object ACLs. Since all objects now share the same configuration, it's much easier to tell if any objects are publicly exposed to the internet. By inspecting your bucket policy, you can quickly determine who can or cannot access your data. Uniform bucket level access also helps you leverage a security feature called domain restricted sharing, which enforces that all members of an IAM policy must be within a specified domain. IAM conditions brings attribute-based access control to GCS by extending IAM's policy language with conditional bindings. This recently GA feature allows you to grant access based on a resource name or a request timestamp. A simple example that combines both attributes is if you tried to grant future access to all objects whose name started with 2020 slash. I've also included a cell expression at the bottom of the slide that you could use to implement such a condition. Some of you may already be familiar with user account HMAC keys, but I'd like to introduce you to service account HMAC keys, which are now GA. Service account HMAC keys are similar to user account in that they're also a type of credential that can be used to create signatures, which you can include in your requests to GCS. These signatures show that the request is authorized by the entity that owns the HMAC key, delegating that entity's access to the request. You manage service account HMAC keys by calling our APIs to generate HMAC credentials, which consist of an access key and a secret. So if you're already using user account HMAC, there's no need to change your code. You can simply update the access key and secret that your code is using. With service account HMAC, you'll also get better key lifecycle management. From the Cloud Console UI, you can quickly create, rotate, disable, and delete your HMAC keys. And lastly, Service Account HMAC is interoperable with other public clouds, which will enable your app for multi-cloud. For customers who work with multiple public clouds, GCS has also gone GA with our V4 signature support. V4 enables you to access multiple object stores with the same client code, and it's available for both RSA and Service Account HMAC keys. Now, I'd like to show you how these features can help you secure your data at scale. To start, I'll go over fundamentals like org policies and the differences between Cloud IAM and GCS ACLs. I'll also explain how uniform bucket level access simplifies access control at scale, and then I'll conclude with some best practices for using HMAC keys with GCS. Within GCP, all resources conform to a resource hierarchy. GCS is no different. Your buckets hold objects and they're associated with projects, and projects can be nested inside folders and are tied to organizations. Org policies are settings that you configure at the org, folder, or project level to enforce a service-specific behavior. So remember that all resources inherit from org policies set higher in the hierarchy. So if you set an org policy at the org level, it would cover all GCS buckets in its tree. And lastly, org policies themselves are not retroactive because they take effect after they are enforced. So hypothetically, if there was an org policy that prevented buckets from being created in a specific region, enabling it now wouldn't impact any buckets that were created before that org policy was enforced. The two org policies that we recommend enabling with GCS are domain restricted sharing and uniform bucket level access. The first one prevents users from adding members outside your organization to IAM policies controlling access to your GCS resources. So if you tried to make the contents of a bucket public to the internet by adding all users member to the bucket policy, this org policy, when enabled, would block that operation. And I'll cover this in the demo. The second org policy enforces the use of uniform bucket level access. So after you enable this, all newly created buckets are required to manage their access uniformly through the bucket policy. And this is also covered in the demo. The easiest way to set an org policy is through the Cloud Console UI. For certain org policies, like domain restricted sharing, you will need to know your organization's domain ID as well. And if you don't have it, totally fine. You can always use gcloud to find it. I'd like to go over a brief history of GCS access control. In the beginning, GCS only supported ACLs, and then Cloud IAM came along, and GCS integrated with IAM at the bucket level. So today, when you configure access to GCS, you should be aware that there are actually two systems at play here. There's Cloud IAM and there's GCS ACLs. Access can be granted from either system, but Cloud IAM behaves like org policies in that they also follow the resource hierarchy. So any object permissions, when granted at the bucket level, they automatically apply to all objects underneath that bucket. GCS ACLs, on the other hand, they do not follow the resource hierarchy. They are used at the object level and can only grant access to individual objects. In general, we recommend using Cloud IAM to authorize access to GCS because it is integrated with so many security and privacy features like domain restricted sharing and cloud auto logging. Since objects can have unique ACLs, it gets harder to tell who has access to your data the longer your bucket has been in production. Imagine having to iterate across millions or billions of objects in order to check to see if a specific user is granted or denied access to any objects. You can see that this can quickly become a maintenance burden. And our recommendation for managing lots of object ACLs at scale is to not manage them at all. By enabling uniform bucket level access, you are disabling object ACLs and using the bucket policy for all access control. Every object is treated the same, and every object benefits from all of IAM's feature integrations. An added benefit to using this feature is that GCS can now share access decisions for objects within the same bucket. Caching is improved, which is great for high QPS use cases. And we understand that some of our customers continue to use GCS ACLs for different reasons, whether it's because of their multi-cloud architecture or because ACLs allow you to share an object with an individual user. In general, it is not a best practice to put end users on your object ACLs, so I'd like to recommend some alternatives. First, sign URLs. Sign URLs allow you to delegate time-limited access to your GCS resources. Your code generates a URL which contains authentication info in the query string that's tied to a specific identity, usually a service account. And that URL is sent to an end user for download. Second, if you notice that certain groups of objects happen to share the same access pattern within your bucket, like they have the same object ACL set, then this might be a sign that you should be using separate buckets, one for each use case. And lastly, if your app makes use of shared prefixes in object naming, then you could also use IAM conditions to shard access based on those prefixes. And finally, I'd like to explain some best practices when using HMAC keys on GCS. First off, we recommend service account HMAC over user account HMAC. Service accounts in general, they offer more reliability because they are tied to the lifetime of a cloud project, whereas user accounts are not. The user account can easily be deleted outside the context of GCP. For example, when a collaborator leaves the organization or when an employee leaves the company. If this happens, deactivating that user account would also deactivate their HMAC keys. And this would result in access denied errors for any code that was relying on those keys. So we definitely recommend using service account HMAC keys in a production service. Other things we recommend rotating your keys and only granting your service accounts just enough permissions to accomplish whatever task they're trying to do. And lastly, if you're using V2 signatures, we recommend setting reasonable expiration times, as well as eventually migrating to V4. V4 enforces a max time limit of 1 week, whereas V2 has no limit, which can be risky. All right, time for a demo. All right, let's begin the demo by enabling the org policies that I mentioned in the best practices section before. So to do this, we'll go to the org policy editor, and we will configure domain restricted sharing and uniform bucket level access. So let's start with the first one. And for domain restricted sharing, you're going to need your domain ID. And if you don't know that off the top of your head, no worries, you can use gcloud to list the organizations that you have access to. You can see here I have a test org, and this value on the right is going to be my domain ID. So I'm going to throw that here into the policy value, select save. Great. Now only members of this domain ID are allowed on IAM policies anywhere in my project. Go back to this org policy view, select enforce, and we will customize and set the enforcement on as well. So now that I've configured this org policy for uniform bucket level access, any new bucket will have to use that feature, which will greatly simplify access control across objects in buckets. From here, let's go to storage browser and see these org policies in action. So we create bucket. Let's call this bucket GCS next on air. We'll use the defaults for data location and storage class. And we can see here that the org policy I enabled earlier enforces uniform for access control. I'm going to create the bucket now. And let's make sure domain restricted sharing is also in effect as well. So to do that, we'll go to permissions, and we'll try to add something that's outside the domain. If I were to add all users, which would grant access to everyone, making the bucket publicly exposed on the internet, that would violate the domain restricted sharing org policy. And so I am expecting this to fail. And we see that the policy update failed, and it's because the org policy was put in place. So that's great. If we can't add all users as a member, who can we add? Well, most of the time when you run a production service, you want to use service accounts. So prior to this demo, I had created an object viewer service account. It doesn't actually have object viewer permissions, but I just named it object viewer just for the sake of simplicity. So if I go back to storage browser and I update the permissions here, I should be able to add that service account to my bucket. I'm going to give it the same permission that I tried before, storage object viewer, which has read access to objects. And I'm going to select save. And because this is configured at the bucket level, my service account is going to have access to all objects within this bucket. As you can see, I haven't added any objects yet, so I'm going to go ahead and do that now. Here I have some folders that have some text files in them. Let me drag and drop them here onto the UI. All three folders have different prefixes, but they all have the same text files in them: apples, bananas, and cherries. So how do we confirm that our service account actually has access to all these objects? Well, easy way to do it is to use service account HMAC. You go to settings, interoperability, create a key for your service account. I already have a key set up here, but I don't remember the secret for it, so I'm just going to go ahead and make a new key. If I go over to terminal you can see that I have this get object metadata with HMAT key script. This script reads from environment variables that I have to export. So I'm going to go ahead and do that now. Exported the access key, and we'll do the secret next. Great. So now if I run this script and I try to access my bucket's objects, I should see that access is granted. And you can see that we have successfully fetched the metadata for this object. Let me try some of the other files. Looks like access has been granted. Great. So if we go back to the browser, I mentioned earlier that I wanted to show you an example of IAM conditions. So with IAM conditions, you could set an object prefix, which would limit the access to objects with a certain prefix in the name. So instead of granting access to every object in the bucket, let's say I only wanted to grant access to those with 2020 in the name. So to do that, go back to the bucket permissions page. I don't need to add the member because the service account is already on the bucket policy. All I have to do is edit it. So from here, I can add a condition. Let me call it 2020 prefix. And for condition type, we'll do resource name, starts with, and we have to specify a resource name format. So the format's different for each GCP service. So this table right here is really nice. And you can see that Cloud Storage Objects follows this format. So I'm going to grab that, copy it in here. For object name, it's not an object name. It's going to be a prefix. I'm going to do 2020/. And for bucket name, I'm going to put GCS next on air for the bucket. Click Save. Now that I have this set up, I'm going to check to make sure that I have access only to 2020 and not the other two. 2018 should fail now. Access denied. 2019 should also fail. We'll try some other files. Also denied. But if we make it 2020, access should be granted. Great. And that's how you set up a object prefix IAM condition. And with that, that concludes the demo. Thank you very much.
Thank you, Chester. To conclude, as you have seen in this session, GCS offers planet scale object or blob storage with a simple and unified API and online latency characteristics, and it addresses a whole wide range of use cases we see customers use this for. Security is built into GCS by design and default, not as an afterthought. And as you saw from the various GA features that Chester just talked about, we are continuing to innovate and invest very heavily in the security capabilities to address your requirements and concerns. With GCS, you can confidently store your data at scale and trust us to keep your data secure and safe. With that, I would recommend, if you haven't yet tried some of these GA features, or if you haven't tried some of these security best practices that we just covered, give it a shot and let us know. Thank you.